Yes, sir, my name is Nick, and today I will be presenting on a topic called Introduction to YACC, which is an automatic parser generator and how it plays a crucial role in automata and compiler design. So basically, this topic is a part of automata and compiler design course, and this presentation will let us understand and helps us build our communication and technical explanation skills. Now, let's get started. Now, let us understand first the compiler basics, the journey from source code to machine code. Before we understand YACC, let's quickly review the compiler pipeline. The compiler converts the source code into a machine code through various steps or stages. Now, let us understand each step or each stage one by one. Coming to the first stage or first step, which is lexical analysis. Here, the source code is broken down into smaller, meaningful units called as tokens. Here, the tokens can be keywords, identifiers, or operators. For example, we have a code int x equal to 10. Here, we breaks our source code into tokens such as int id equal to num or and also the semicolon. And the second stage is called as syntax analysis, also called as parse. This stage checks whether the sequence of tokens follows the grammar rules or grammatical rules of the programming language or not. If valid, it builds a parse tree. And as you can see in the compilation pipeline diagram, parsing sits between the two stages, that is the lexical analysis and the syntax analysis, or between the raw tokens and the structural meaning. This is the bridge where YACC comes into the action. Let us understand what is YACC. YACC stands for yet another compiler, which is the parser generator. It is an LLR parser generator, meaning you give it a set of grammar rules, and YACC automatically creates parsers from grammar specifications, and it writes a C program that can pass structured input according to those rules. And YACC was developed by Stephen C. Johnson at Bell Labs, and it was originally originated as a part of Unix operating system. In the modern world, GNU Bison is the standard replacement for it. And we can see a fun fact, that is the name YACC reflects its humble origins, that is it was just yet another tool in a long line of computer compilers that is being developed at that time. Let us understand how YACC fits in. So how does actually YACC fits into the development process? We start by writing a grammar or grammar specification file with a .y extension. This file contains your grammar rules and token declarations and optimal C code. So you then run the YACC command on this file. YACC processes your grammar and generates a C parser file, typically named y.tab.c. So this file actually contains the function YYParse, that is, which is the actual parser. This generated parser can then be compiled and linked with the other files to create a complete executable. So YACC completely automates the parser implementation. You don't write parsing logic by yourself. It actually helps you write that. Now, let us understand why do we need YACC. So basically, let me ask you a question. That is, why do we need the YACC? Why not write parsers manually? That is, why not we do our work by ourselves? So basically, writing a parser manually is a time-consuming work. It can take weeks of development for complex grammars, and it is error-prone because complex state machines are hard to debug, and it is hard to maintain. Any grammar change may require major rewrite, so it becomes very difficult for writing by parser. Now, with YACC, that is, by using YACC parser, the development is fast. We write grammar rules and generate the parser instantly. And it is reliable because it is user proven and well tested parsing algorithms. And also, it is very easy to modify. You simply update the grammar and regenerate. So, by this process, it will be like very fast development. Think of it this way, that is, manual parser writing is like cutting a book with a handsaw. That is slow, it takes time, which is tiring and imprecise. Whereas by using YACC, it is like using a power saw, that is, which is fast, precise, and efficient. So you get to focus on language design instead of a parser mechanics. Let us understand how actually YACC works, that is from grammar specification to executable parser. A YACC file has three mandatory sections separated by two percentage symbols. The three sections of YACC file are declaration, grammar rules, and auxiliary routines. So in declaration section, here we define our tokens using percentage token, specify the start symbol using percentage start, and include any C headers or global variables inside percentage and open brackets and a bit of dots and percentage and closing bracket. And in grammar rules section, here we write our grammar in BNF like notation. That is, here we have an example. That is, we have an example that is expression where expression plus term or term. So this comes under the grammar rules section. And also we have auxiliary routine section. Here we write our grammar like a C functions such as a main function or YA parse or YA error, like any function. That is, we write by using a C language function. And now YACC generates a LALR1 parser. That is, LALR1 stands for look ahead, left to right, and right mode derivation with a one token look ahead. And it is a bottom-up parser which builds tree from leaves to the roots. And it is a single token look ahead which makes decision with one token preview, which is why it is called LALR1. And it runs in a linear time, which is having a linear time complexity that is big of n, making it very efficient. Let's understand YACC LEX, that is lexical analysis or lexical analyzer, the perfect partnership. YACC is almost used together with Lex or Flex. They form a perfect relationship. Lex is a lexical analyzer generator. Its job is to break the input into tokens using regular expressions. That is, for example, we have a various patterns that is 0 to 9 plus, which becomes a number. And we have alphabets plus, that is, which is an identifier. And we have various operators. So basically, analogy is the Lex is like a breaking a sentence into individual words. And YACC is the parser. Its job is to validate the token structure using grammar rules. Analogy is YACC is like understanding a sentence grammar. That is, it might be subject, verb, or object. And together, Lex handles the what, that is the tokens, and YACC handles the how part, that is the structure. This completes the parsing pipeline from source code to parser structure. Hence, it forms the best and perfect partnership. Now, let us understand what are the grammar rules and how parses will be built based on the examples. Now, let me show you how grammar rules and parses work together. Here is a simple grammar in BNF notation. Here, we have an example grammar that is expression can be EXPR or expression plus term, or it can be just term. Like EXPR can be just EXPR, that is plus term or just term. And here term can be term star factor or just factor. And also coming to another example, that is the factor can be number or an expression inside the parentheses, that is expression. And now let us take the input, or this could be various example grammar. Now let us take the input, that is 3 plus 5 star 4 or any other example. Now let us build a parse tree from here. The parse tree shows that multiplication happens before the addition because the term inside the EXPR or expression, the tree builds from the tokens upward, showing operator precedence of very clear. And this is how YACC values syntax by building a hierarchical parse tree from the bottom up. Now let us understand how automatic parser generation works by using step by step. So here we are building a calculator with YACC so that we can understand it better. The first step is Create a klc.y file with token declarations, grammar rules, and for addition and multiplication, and a main function, just like the C program. And the step two is running the YACC file or YACC parser by using the command that is YACC minus D calc.y, where calc.y is a file. And this generates two outputs, that is y.tab.c file, which is the parser, and y.tab.h, that is the header file with the token definitions. And the step three is compilation stage, which is build executable. And we have to run we have to run that following command, that is gcc y.tab.c minus ly minus ll minus lm minus o calc, which is the file name. And this compiles the generated C code into an executable called calc. Now we are gonna test or we are gonna run our calculator with these steps that we have processed till before. And after running the calc file, or that is our calculator, that is via type an expression, that is we have to give an input such as 2 plus 3 star 4 and press enter. The calculate performs all the steps and outputs the compiled result, that is 14. So basically this is the complete workflow of an automatic parser generation by using YACC parser. And that's the magic. You just define the grammar rules and YACC handles the rest. Now, let us dive into real-life applications of YACC parser, where YACC makes a difference in the real world. So, YACC isn't just a teaching tool, it is used in real-world and production systems. So, the first one is programming language compilers. GCC used Python, that is GNU YACC for C++ or C parsing until 2006. Early Java compilers also used YACC-based parsers, and OCaml also uses for its parser and powers the tools developers use daily. So basically, these tools are very much useful for the developers to develop an environment. And the second one is domain specific languages. This is perfect for creating custom languages for specific domains. And SQL parsers in databases use YACC parser to process query language. Configuration file parsers and network protocol analysis parsers are purely rely on YACC. And the third one is calculator applications. The Unix PC calculator uses YACC. Scientific calculators, financial interest calculators, and unit conversion local calculators often use YACC based parsers. And the last one is web and form validation. The parser being structured data in web application and form inputs. And URL parameter parsing, JSON and XML parameters, and complex search query parsing all use parsing techniques similar to what YACC provides. These are the various real-life applications based on YACC parsing. Now, let us see how a compiler understands both natural language and code. That is, those are the various challenges that a compiler would understand. So on the left, we have the sentence, that is the cat sat on the mat. So first, lexical analysis breaks it into tokens like words, that is the cat sat on the mat. Then the YACC applies the grammar rules to identify the parts like subject, verb, and object, and finally builds a parse tree from this, showing the relationships. Now on the right, we have a code example, that is there's an if condition that if x greater than 5, y equal to x plus 10. The compiler first breaks it into tokens like if x greater than 5, y equal to plus and 10. Then YACC checks the grammatical rules or grammatical syntax errors of the code, and it recognizes this as an if statement with a condition and a body. Now in the parse tree, the top node is the if statement. One branch represents the condition, that is x greater than 5, and the other represents the body, that is y equal to x plus 10. The structured tree helps the compiler understand the logic and ensures the structure is used and correct. So whether it's an English or a code, the process is the same. We generally use lexical analysis either on the text, either on the code, that is tokenize, apply grammar rules, and build the structured parse tree. Now let us understand the advantages and limitations of YACC parser. Coming to the advantages, we have automatic generation, where it produces or it performs parsing very fast, where there is no need to code complex state machines by hand or by man. And other one is proven and reliable. Hence, it has been used by 50 plus years of use in production compilers. Hence, it is a well-tested LALR1 algorithm. And the next one is efficient parsers. Hence, it has the linear time complexity big of n. It is fast and memory efficient parsing. And the next one is Lex integration. That is, it seamlessly works with Lex for complete compiler front. And coming to the limitations, it is LALR, one constant. It cannot handle all context-free grammars. Some grammars need rewriting or should be solved by man. And conflicts are it shift reduce and reduce conflicts require manual resolution, cannot be solved by YACC parse. And the learning curve requires understanding of parsing theory and grammar formalisms. Without any knowledge or prior knowledge about this, we cannot solve or we cannot use this. Error recovery. Limited built-in error recovery mechanisms needs custom handling. It cannot solve all the problems. And the modern world alternatives are first one is Bison GNU YS's replacement with more features. And the next one is ANTLR, that is LL star parser generator with IDE support. And the next one is handwritten, that is recursive descent for full control. Now let us understand all the key takeaways that we have to learn from this presentation. The first one is automation. YACC automates parser generation from grammar rules, saving weeks of development so that we can perform all our tasks so much faster, which reduces weeks of development time. And the next one is partnership. And here we have already discussed the perfect relationship between the Lex and YACC, which is a complete compiler front end. Lex handles all the tokenization, while YACC handles parsing, which is a perfect combination. And the next one is LALR1 algorithm power, which is YACC generates efficient LALR1 passes with linear time complexity, that is, which is big of n, with 50% or which is 50 plus years of experience in production compilers. And the next one is real world impact. From GCC to calculators, YACC powers tools developers use TEL. Understanding YACC opens doors to automated compiler design. So there are few next steps that we can explore. The GNU Bison, modern YACC, try building a calculator and dive deeper into compiler design. And if there's any questions, and I'm ready for discussion. Thank you.